faithfully delivering value, interpreting the world's best books. Hello, this is Sally's Book Talk. Today's book for you is The Lean Startup. What is the lean startup? The term lean comes from Toyota's lean production in Japan, characterized by small batches, rapid manufacturing, real-time monitoring of issues, and timely adjustments to maximize customer satisfaction. Any step not aligned with customer needs is seen as waste and eliminated. This system helped Toyota stand out in global car competition in the 1970s and 80s. Currently, it remains the world's top-selling car brand. IMT conducted extensive research in the International Motor Vehicle Program, comparing and concluding that lean production is the most suitable organizational method for modern manufacturing. IMT. The author of this book, Eric Ries, is a software developer from Silicon Valley. He believes Toyota's approach is also applicable to internet startups. Hearing this, someone might ask, traditional manufacturing and internet startups, from product creation to marketing, their logic seems totally different, so how could it apply? The author's research found that most startups fail for two main reasons. First, when a new product launches, it often has an extremely high growth rate.
Entrepreneurs get misled by these seemingly impressive metrics, thinking the product model has no issues.
Second, internet entrepreneurs often resist traditional management, fearing it causes bureaucracy or stifles creativity. So, many adopt a just-do-it attitude with high freedom, avoiding any management. This approach can lead to major directional problems in the product, causing the company to lose users by ignoring details and ultimately collapse. Therefore, the author argues that internet startups should learn from traditional manufacturing management, where the core is high-quality physical products. The internet industry's core is virtual products that gain user approval. Both must identify and fully satisfy user needs. The exploration process is no different. Both require controlling processes and details, managing chaos and trivial tasks. So, the author combined the concept of lean production and summarized the core idea of this lean startup methodology. Enterprises should engage in validated learning, first launching the simplest product with core features to the market. Then, through continuous experimentation and learning, verify the product with minimal cost and effective methods to see if it meets user needs, and flexibly adjust direction. And if the product doesn't meet market demand, it's best to quickly eliminate it. Also, if the product is accepted by users, continue learning, digging deeper into user needs, and iteratively optimizing the product. So, how did the author summarize this lean startup concept? This starts from his personal entrepreneurial experience. Around 2004, the startup company where the author worked wanted to create an IM software, which is instant messaging software like QQ, MSN, WeChat, etc. Around 2004, there were already 3 mainstream IM software in the US, launched by AOL, Microsoft, and Yahoo, along with about a dozen others from various companies. If you use IM software, you know that QQ users often form one circle and MSN users another. If all your friends are using QQ, it's hard for you to proactively download MSN. The author's startup team, from the developer's perspective, they also thought that when all users are using one IM software, to get them to accept a new one, you need to convince users to switch along with their friends. And this is obviously very difficult. Based on this assumption about user behavior, the author's team thought making a new IM software was unrealistic, and instead decided to develop an add-on product for existing IM software. All right, so they planned to develop an add-on software that could interoperate across various IM platforms. No matter what IM software you use, just enter your ID in the new software to get a 3D avatar and some clothing items, and you can still chat with friends in your original IM software. And you can think of these virtual avatars and clothing items from the author's company as the American version of 2Q Show. The author was the chief technology officer, responsible for the entire software development. and the company planned to complete the product in 6 months. The entire R&D team pulled countless all-nighters and finally launched a fairly polished version before the deadline. But embarrassingly, after the software launched, nobody downloaded their meticulously designed features. The shortcomings they feared users might reject suddenly became meaningless. In desperation, the author's team invited young people to their studio to personally teach them how to download and use the software. They asked about their experience to understand their thoughts through face-to-face conversations. After interviewing about a dozen young people, the author's team discovered a serious problem. Well, the IM add-on software they developed had a fundamental flaw. Young people join new IM software not to move old friends to the new platform, but to meet new friends there. Young people aren't actually opposed to joining new IM software as long as it's interesting enough. They're very willing to try and meet new people. They already have 7 or 8 different IM apps on their phones, with different friends on each platform. The team's new virtual avatar feature wasn't compelling enough to be a must-try, and since it didn't help meet new friends, they naturally weren't interested. The user feedback almost overturned all their assumptions, meaning their 6 months of effort were completely wasted. The author reflected, why spend 6 months building the product before getting this information? Why not use easier methods earlier to clarify user needs and avoid such waste? The essence of product development is working smartly according to users' real needs. So, how do you work smart? That means using the most scientific methods to gain validated learning as quickly as possible. Validated learning is a new term coined by the author, meaning concepts confirmed through actual user interaction. What's the most scientific method? Naturally, it's conducting experiments. Recall how scientific experiments are done. We start with a clear hypothesis, predict outcomes, then run experiments to gather validation data to test whether the hypothesis holds. For businesses, experiments work the same way. First, establish a hypothesis and develop a product. Then let users experience it to test acceptance. Gather feedback from users, then iterate and adjust to launch a refined product. The author summarizes this process as the build, me, measure, learn feedback loop. Building the product, measuring data, and gaining insights, the core of his lean startup theory. In practice, this process is divided into 4 steps. Step 1. Establish hypotheses by first identifying what the company needs to know.
Step 2. Validate these hypotheses using systematic methods to gather data.
Step 3. Analyze the data and make adjustments for improvement. Step 4. Finally decide whether to persevere with the product or pivot. Now let's break down each step. First, establishing hypotheses. Assuming users have an unsolvable problem that you can provide a solution for. If users pay for your solution, you generate revenue. But behind this simple logic lie 4 complex questions. Is your solution addressing the actual problem users face? Even if you have a solution, will users actually pay for it? And with numerous solutions available, why would they choose yours specifically? Can your solution accurately solve users' problems? In reality, entrepreneurs often only address the 4th question, focusing on whether their solution works, while neglecting the first 3 questions. But the author argues the first 3 are crucial as they encompass 2 key entrepreneurial aspects. The first is the value hypothesis, answering question 1. Does your solution solve users' actual problem? Companies must determine what product to develop and whether users actually want it. For example, the author's software failed because it didn't address making new friends, losing its core value. Take Zappos. When founded in 1999 during early e-commerce, founder Tony Hsieh urgently needed to validate the value hypothesis. The value hypothesis: physical stores carried limited styles regionally, restricting consumer choice. Could a nationwide online shoe store solve this consumer problem? The second is called the growth hypothesis.
The growth hypothesis answers questions 2 and 3.
If you have a solution, will users pay for it? With so many alternatives, why would they specifically buy from you? What's appealing about your solution? And attracting one or two users isn't enough. How do you get more users to discover and love the product? How can you make product sales grow continuously? Is it through massive advertising to attract new users, having existing users refer others, or first offering a free product to attract users before gradually charging? All these need to be validated one by one. With hypotheses established, we move to step 2, scientific and reasonable validation. What should we use to validate these hypotheses? The author uses a professional term, minimum viable product. Abbreviated as MVP, it's the simplest product that demonstrates core functionality. For example, as mentioned earlier, Zappos' founder wanted to validate whether consumers would buy shoes online. He created a website, went to local shoe stores to photograph shoes, and uploaded the photos to the site. If someone ordered, he'd buy the shoes from the store and ship them to the customer. This simplest website was Zappos' MVP. No warehouses, no stable supply chain. Yet this method most directly validated Zappos' value hypothesis. However, sometimes due to funding and time constraints, even core features can't be fully demonstrated. For instance, the author's company wanted to launch new 3D avatars that could walk around when loaded into user IDs, but the team lacked resources for polished animations, yet needed to validate if young people would like this approach. So they made a simplified version where avatars teleported to mouse-click locations instead of walking. Though lacking walking animations, it still demonstrated the core functionality. In other cases, technical limitations may prevent even a decent prototype early on. For example, when Dropbox started in 2007, they wanted a shared folder where dragging files would auto-upload to their servers, then sync to all the users' computers and devices. This is essentially the cloud system that people commonly use today. But back in 2007, this functionality was still a novelty. Dropbox couldn't create a prototype product in the early stages because engineers needed to integrate different computer and mobile operating systems, which was a major technical hurdle. So Dropbox created a 3-minute video showing how the synchronization feature would work. In this case, the MVP was just a small video. For these very simple or even rudimentary products, the author emphasizes that startups should set aside traditional professional standards, not pursue perfection, and quickly move into the validated learning phase. With the MVP in place, the next step is the core part of the second phase. Doing experiments. How do you conduct experiments? First, measure the real data at the current stage. After developing the MVP, startups can sell it to real users through primary marketing channels. At this point, the company can get its first batch of real baseline data, such as registration rate, usage rate, and conversion to paid rate. Even if it's all bad news at first, it's still very valuable, because these establish the baseline metrics for each subsequent hypothesis. Next, gradually adjust from the baseline to the ideal state. For example, if the initial conversion to paid rate is 1% and the company's ideal is 10%, the company can try various methods to move closer to 10%. These two experimental processes, the author's advice can be summarized into 2 points. First, if a startup has multiple hypotheses, prioritize testing the most challenging one. For instance, a media company focused on car content typically has 2 basic hypotheses. Can it attract car enthusiasts' attention? If it has 100,000 car enthusiast fans, can it successfully find car advertisers to place ads? Among these 2 hypotheses, the more challenging one is whether it can attract enough car enthusiasts' attention. We therefore choose this hypothesis to test first. If you can't find a way to attract enough followers, it's impossible to build a sustainable business, and there's no need to test whether you can attract advertisers. Second, conduct comparative testing. For example, there's a learning app offering U.S. university courses. Developers continuously validate new features through comparative testing. First, it had teacher lectures, then enabled student interaction for some users, while others kept the original version. Later, it added learning check games for another user group. Through each comparison, developers see whether new features gain user acceptance and attract more users. Without comparative testing, when users reject a feature, teams must backtrack to find causes and can't confirm if growth comes from new features. With comparative testing, teams directly see relationships between new features and user growth. During comparative testing, the author emphasizes small batch testing. Consider this example. At year-end, your company needs to mail thank you letters. You must stuff 100 envelopes, seal them, and add stamps. How can you finish faster? Stuff all letters first, then seal all envelopes, then add all stamps. Doing one task at a time, wouldn't that be faster than processing each envelope fully before the next? In lean production, stuffing all letters first, then sealing all, is called batch processing. The batch method completes each step uniformly before moving to the next. Completing one envelope fully before starting the next is called single-piece flow. Actually, single-piece flow is more efficient because batch processing hides problems until too late. Say you miss stuffing one letter, you only discover it after stuffing all 100 envelopes. Then you must recheck every envelope. Or after stuffing all, you find envelopes won't seal properly and need replacing.
In that case, all stuffing work was wasted.
But with single-piece flow, problems surface immediately for quick fixes. Similarly, in business, small batches catch errors early, preventing reputation-damaging mistakes from reaching customers. This is how the author's team operates. Instead of designers just bulk designing products, engineers buried in coding for development, and testers doing bulk testing, designers, engineers, and testers form a team to collaboratively develop a new feature. During one development cycle, they encountered an issue. An engineer accidentally set the checkout button on the payment page to white, placed on a white background. From the engineer's perspective, he had completed all functional development. From the tester's perspective, the button was still there and working fine. But from the user's perspective, the button disappeared, so they couldn't buy anything, which had a massive impact on the business. If a development batch has many tasks, such problems are hard to detect quickly. But since only this one feature was deployed, the team quickly found and fixed the issue. Therefore, small batch testing is a crucial principle in lean startup. It's vital to implement small batches effectively. The author recommends introducing Kanban management from lean production, drawing 3 boxes on a whiteboard. Each box represents an item's progress. In development, development complete, and validation complete. The item must be validated before it can be removed from the whiteboard. Most importantly, only up to 3 tasks can be in development simultaneously. If an engineer finishes 3 development tasks, but validation isn't done, he can't start new development. He must join validation until everything is complete before taking on new tasks. Through various tests, a large amount of data was generated. So which data should be focused on and how should it be analyzed? This brings us to the 3rd step of lean startup. Many entrepreneurs might think rising product growth rates or increasing revenue numbers mean they've hit a milestone. But in reality, for startups, aggregate data can be highly misleading. For example, the author's team monitored data and found registrations were 40,000 in June 2005 and 105,000 in September 2005. In just 4 months, registrations more than doubled, seeming very promising. The author calls such metrics vanity metrics, which greatly satisfy entrepreneurs' vanity. But for software, the most crucial data is how many people are actually using it and how many users are willing to pay. Registrations without usage mean no real growth. Analyzing from another dimension. What percentage of registered users actually log in? June was 29.6%, July 22.3%, August 22.4%. Reality isn't ideal. Promotions drive signups, but users don't engage. The author calls this cohort analysis, meaning analyze each user group's behavior, not vanity metrics like total users.
Companies with different growth models focus on different data. Many use sticky growth.
Users try the product, stick around if it's fun, or uninstall if boring. Here, the key metric is user retention rate. For example, 39% new user growth, but only 60% retention means 40% churn. The company seems high growth, while active users secretly decline.
This is dangerous. Companies must assess content appeal and reward systems.
Some use viral growth, like WeChat Moments likes. If someone posts an ad meeting 50 likes and 10 sign up, they brought 10 new users. With 100 such posts, you get 1,000 new registrations. The key is how many new users each referral generates, the viral coefficient. This number requires close monitoring. If the coefficient drops, growth is slowing. Then ask, is the market saturated? Or do posters lack influence? Are incentives insufficient for viral loops? Others use paid growth, gently, buying Google or Baidu ads, partnering with Twitter or Weibo influencers, and offering coupons like spend $20, save $2. All these marketing campaigns and promotions require significant costs. So how much are users ultimately willing to spend on the product? Two key metrics matter: revenue per customer versus cost per customer. If revenue is far below cost, the business stays in the red. Should the company reduce acquisition costs or raise prices to boost per customer revenue? In short, data shows whether the company is moving from baseline toward its ideal standards. Should they try different promotions or tweak product features, then revalidate and gather new data? After multiple build, me, measure, learn cycles, substantial data accumulates. This data reveals whether the company is improving from its initial MVP baseline toward targets or failing to progress despite efforts. At this point, the company must make a critical choice. Should they persevere or pivot fundamentally? Most entrepreneurs struggle to pivot due to fear. Admitting failure might demoralize the team, and they cling to hope that persistence will eventually turn things around. But the author warns, this stubbornness is dangerous. Experimental data doesn't lie. If every improvement fails to approach targets, the product likely has fundamental flaws. Continuing down this path guarantees failure. Plus, startups have limited pivot opportunities. There's a term in startups, runway length, how long funding lasts before crashing. But the author argues cash reserves alone shouldn't define runway length, because struggling companies often seek more funding or cut costs. Securing extra funds helps, of course, but relentless cost-cutting slows feedback loops, nearly delaying the inevitable. The true runway metric, remaining pivots, opportunities to radically change strategy. Each pivot consumes significant funds as the company shifts to a new business model. If successful, it might extend the runway. If unsuccessful, pivot again and validate a new direction. For example, $1 million in funds, no product traction, 100,000 monthly expenses. Is the runway 10 months? No, that's just the countdown to failure. True runway depends on pivot costs. Say pivots cost 500,000 each. 2 attempts allowed before funds exhaust.
A successful pivot bringing 1 million revenue extends the runway.
Thus, runway length equals how many pivots remaining funds can support. Pivot types include zoom in, focusing on one feature, or zoom out, becoming a feature in larger product. Growth engine pivots change strategy, viral to paid growth or hybrid. Channel pivots alter sales distribution, wholesale to direct to consumer.
Others, customer need pivot, segment pivot, platform pivot, value capture pivot, tech pivot.
Choosing a pivot direction means establishing a new hypothesis. Then the entire build, measure, learn loop restarts.
The author asserts pivoting is the core of lean startup methodology.
If tools detect product market misfit and tests reveal viable directions, rapid adjustment is crucial. All right, that concludes the book summary. Recap. Lean Startup's heart is the build, me, measure, learn loop. Develop products, measure data, gain insights to rapidly validate user needs. Finally, after multiple cycles, decide, persevere, or pivot. However, critics exist, like Silicon Valley's godfather of VC. Peter Thiel, author of 0 to 1, remains a staunch lean startup critic. He believes that companies using the lean startup method are feeling their way across the river constantly moving forward through trial and error, showing they actually lack clear planning. Moreover, the constant rapid adjustments in lean startup mean it can only achieve incremental innovations, not disruptive ones or groundbreaking products that predict the future. Many scholars also argue that in detailed operations, lean startup can cause biased results due to subjective biases. For example, measured data might have noise, and much of it is actually unusable. Another example is that different people interpret the same data differently, leading to totally different conclusions. Plus, many issues actually can't be quantitatively analyzed. But since this book came out in 2012, over the past decade, many startups' growth has validated this theory's feasibility. Therefore, it's been highly praised in Silicon Valley startup circles, with many companies seeing it as the startup Bible. The author also upgraded his theory in 2020, fixing lingering pain points from lean startup, and wrote a version 2.0 that focuses more on practical management. Uh, That wraps up our discussion of Lean Startup 2.0. Reading notes are below the audio. See you next time.